This is Shakil Ahmed. In this tutorial, we will discuss about multiple linear regression. Multiple linear regression is used when we have more than variables in our regression model. We have only one dependent variable and more independent variables. This is also called multivariate, multivariable linear regression. But multivariate is different. Multivariate regression, we also may have more than two or more dependent variables. So keep in mind it's multivariable regression model. So we start with a data set. Again, the stroke data set, and we want the we want to run a linear regression of average glucose level on a set of variables: age, that is a continuous variable, gender is a numerical variable, and numeric variable, and the status is a categorical variable. These are converted to numeric variable. Basically, these are strings, and hypertension is also uh, already in form of 0 and 1. So whenever you have this type of string, you need to convert into numeric. Just use the option category codes. Yeah, you just converted gender into gender numeric and marital status into marital status numeric, and it as type, as category and category codes. So it will give 0 to 1 category and 1 to the other category. So we can run this using stats models as SM and the pandas as PD. We do need these two libraries to run, and then we set this vector of y and a matrix consisting axis. We can also add a vector and intercept to the x vector using SM at constant to x, and then model SM OLS y and x, and then fit, and then you can print the model summary. So we to run this. Think we have not uh, we can you can check whether the data is uploaded or not. The data is not uploaded. Basically, I had uploaded, but when the session expires, the data uh, automatically removes from the this list. So you need to upload the data again and download, and I just don't Spox.csv, and then okay, it's here it's mentioned this runtime files will be deleted when the runtime is terminated. So you should keep in this mind, and you can and then you can run the codes. See the results. These are the model performance criteria. R squared, as higher R square values always preferred, but the adjusted R square is more stable to check. And the F statistic, this tells overall significance of the model, and log likelihood, and then AIC and BIC values. Then the main thing is to check the coefficients. These are the coefficients corresponding to different variables, but the interpretation is a little tricky in multiple linear regression. Here, age is a continuous variable, so the beta value, the value of beta is 0.42, around 0.4, 40%, 0.40. So zero point 0.4, you can call it 0.42. It means 1 unit change in x. It means 1 year change in the age will cause 0.42 unit, whatever the level of the glucose, the unit for the level of glucose is 0.42 unit. Uh, this will cause in the glucose level. Keeping other variables as constant or by after controlling for other variables, after controlling for gender, marital status, and hypertension. So we will keep all these variables on their mean values, and it means we are adjusting for these variables, and we are just seeing the association or correlation, the effect of age on the average glucose level. Similarly, 5.32 almost 5.4 gender. So the gender is, for example, 0 for female and 1 for male. So it means uh, we can say that the average glucose level is 5.37 uh, uh, unit higher in males as compared to females. So you can just this is just the difference of the two means, expected value of y and the mean level given that male minus uh, mean glucose level expected value of y given x is equal to 0, that is female. So this is 5.37 and it is the difference between the mean age between male and female. So you can interpret other categories accordingly and other statistics as well. And we have already discussed the different assumptions, how to check different assumptions. For example, linearity, homoscedasticity, autocorrelation in previous lecture. You can see lecture 10 and 11. Now, in multiple linear regression, we need to check for the multicollinearity, that is basically the high correlation between the independent variables included in the model, the IF corresponding to each variable. So again, this from states model, states outlier influence, and then from library we imported variance inflation factor, that is called VIF, and we need to create a VIF data set, data frame, and then VIF for feature X columns. So these are the features. X columns means it will include all the columns of X. And then if data, we are creating, for example, different values, variance inflation factor, X values, and then I. It will basically vary for 1 to number of columns. And for I in the range of X shape 1, it means X shape 1 means number of columns in X variable, and then print VIF result. So you can see the result. All the variance inflation factors are acceptable. If the variance of inflation factor is greater than 10, then we say that that variable is causing the multicollinearity and we should remove that variable from our model. So you can run this again, and if you want to convert into more interactive table, then you can just do this and then copy to Word. And then the next thing is to predict and to assess the predictive performance of the fitted model. So we first need to do model selection. We can do these things in parallel. We basically try to improve our model performance. We have many alternate variables, many options. So we need to check a set of, we need to select a set of variables that predict best the value of the dependent variable. So First, we need to split the data into training and test, and then we will do the prediction, and we can choose the set of variables that predicts the y value best. So we need these packages, model selection, train test split, and from sklearn linear model, we need to import the linear regression, and from the matrix, we need to import R square. If you need other model performance more matrix, you can also do that using the sklearn matrix command, uh, this library, and then import iteration tools. Iteration tools is basically used to iterate set of variables. Basically, I want to select different combination of variables and then check one by one and check which set of the variables gives the best uh, performance measure. So Uh, if gender numeric, we just convert gender to numeric and marital status to numeric, and then add Y and X, and then we split the training X and Y into training and test sets in a ratio of 0.2 and zero point 0.8. Basically, we keep test set as 20% of the data. Run this. You can also see the previous video for this. And then we are creating a best model set and best R square and best feature. So I'm running an iteration from I in range 1 to number of variables plus 1. Basically, we are starting from, we are including intercept as well. So we need to go 1 as intercept, and that is called null model, and variables plus intercept. So, for example, if we have four, and then we select the list of all those combination and called them uh, current feature. So the combination will vary for a combination in this iteration tool combination, all independent variables I. So it will select different set of variables and do the X training sets and X test set, and then run the model and fit the model, and then give the prediction, and then R square, and repeat this process for all combination of variables. For example, start with a null model, then only x1, only x2, only x3, x1, x2, x2, x3. So it will give all possible models and their prediction and their R square. And then if R square is greater than best R square is equal to R square. It means we set the best R square that that gives the largest R square among the all. So it will start from an R square. If R square is greater than the previous R square, then we say that it's best. So it will repeat for all current features uh, that is consist in this list and provide the best R square. So run this command, best R square and best R square. This is the best model consisting all the variables. The last iteration, which is giving the square value of 0.0381, and the best R square is the best R2 that we have obtained here. So, and then best set of features, which set of feature is as considered as best, will give using the one. So we can see the best R square is 0.042. This is the highest achieved R square, and the best set of variable is age and marital status. If we use age and marital status in our model only when it will just R square. So thank you so much for giving concentration. Uh, Write in comment section if you have any confusion or any mistake in the video. You can always write. Thank you.